Okay, so we got the engine out of the frame, sitting on the back of the trailer for a workbench temporarily, and the frame is gone, and so we need to start working on the engine. And so the first thing we're going to do is address a problem with the front head where the intake goes in. The part of the flange is chipped out, and so I suspect that it might be leaking there. So I'm going to fix that, and we'll go on to the next thing. But that's the first thing I want to address right now. So we're going to take off the intake and the carb and the intake, and then we're going to try to weld up that a little bit and see if we can contour it and get it back into shape. Okay, so the first thing we're going to do is we're going to pull this carburetor off of here, because where the manifold clamps to the head, if I remember right, there's a little chunk broken out of it, and I think that allows it to leak, and then that one cylinder runs leaner because it gets more air, sucks some air in there. So I want to check that out before I get to sandblasting. Because I want to do any kind of repairs first. So let's do that, and let's get this thing off of here. Carburetor off of here. See if I can get in here. What size is this? It's going to be tight. I think we're going to have to go for, let's just take it off right there all in one piece. Rusty. Those are going to get changed out with stainless. Anything we can make stainless, we're going to make stainless. Just come out. Those just clamp around it. We might get new ones of those. It's starting to look a little rough. Then you got this brace. We should have took off first. Looks like 7/16. brace will have to be made out of stainless too. Looks like I should stabilize the engine a little bit better too. There's a little bit of binding on here. I'm not sure this thing was set on there real good. Like that. As you can see, it has O-rings in here, and that has to seal here and here. And I don't know if you can see that. I'll give you a close-up here in a minute. This is eaten away. It got chipped out. People not doing things, like some people doing things they're not supposed to. I'm being careful enough. There's the dual throat carburetor. Oh, look at that gas come out of there. Look at that. That's just green. That's weird. Huh. It didn't go in green. Okay. So this is the repair that we have to do next. Alright, let's take you over here and give you a close-up view of it. Alright, so that's what we're going to repair next. Then we'll get to sandblasting, all the fun stuff. But we got to fix that first. That's like top priority. So the first thing we got to do is we got to clean this up. So let's shine that metal up, and then we'll have to measure the bore inside to see what the internal diameter is, and then we'll make a little piece to go in there and go from there. Okay, so the idea is we're going to clean this up, the area that we need to weld, and we're going to clean the inside of the bore up real good, and around it. And we've got to be very careful we can't get anything inside there, because this engine is good and we're not going to tear it down, and we're not going to blow it up either. So that's not in the picture. So we got to clean this up, prep it for welding, and then clean the inside of the bore up, and then we're going to make a little piece, a thin piece ring to go in there on the inside of the bore, and then that will give some support, because this is cast iron. So we're going to weld it with probably nickel 99. You could use silicone bronze, but I will try nickel 99 first, if I can get this thing hot enough, and because you got to get it really hot, and I don't know if we can do that, but then we'll weld a bead over it, clean it up, and because the only real important part is the face right here. That's where the O-ring seals, right in here. And it looks like they could have used a different O-ring. We'll have to do some research too. But this part right here, that part has to get fixed so that it can seal. That's a pretty big hole in a manifold. That's leaking a lot of vacuum. Okay?
Okay, so I took and I made a small thin insert to put in the intake and on the inside. So when I weld it, then it'll hold, the weld from sagging or anything, if later on, if the weld breaks loose, it won't get sucked into the engine. It'll be held in place by that. And so I did that. I used silicone bronze to weld it, and that was a bad thing to do because I couldn't, my cutter, even a carbide cutter would not cut that. It would just bounce right off of the the silicone bronze. It just would not cut it. And so it looked like crap when I was done. I couldn't file it. I couldn't do anything with it. And I'm like, damn. So this is the result right here.
Okay, so this is what I got. It kind of looks good, and then it don't.
So as you can see, it looks terrible. It would not work, and I can't. There's nothing to cut this thing, that I can use, and so we just have to take the head off, put it in the mill, get rid of all that nasty stuff, and put an insert in there.
Okay, we're going to pop this head off here so we can get it onto the mill and straighten this up the right way. Make it look really good. All right. All right. Does, huh? Well, bullseye. Fellas, putting the silicone. All right, all right. Get this off of here. Move this thing off. Excuse me. Gotta blow that off. I guess that's not going to work too good. I'm going to have to put it, I'm going to have to tighten it. Going down a little bit. Got a little dirt at the top of the end. That's not good. Alright. ones we're going to make out of stainless. We're going to make us some good stainless ones. Right now. Now, you can see how this fits. So I got the manifold here, somewhere. I got O-rings sitting in some gasoline so they'll expand. Hopefully. Now this goes on here like this. And it didn't expand too much. Yeah, anyway. Yeah, they're better. They're better. They go on here like this. They go in here like this. Of them. It's kind of hard, but that's the way they go on. Just like that. I gotta make sure don't take too much off of here, because then the gap will be too big for this to fit in there. Like that. It looks like it fits tight. But look how loose this one fits. Too loose. We're gonna have to do something. One of these is wrong. Might have to build up on this or something. I don't know what. We got to make it fit so that it seals, or there's no use to go forward. Uh-oh. 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 Yeah, they're just too dried out. Have to get some new ones. See how they fit. Let's get this head off of here first. It's like it's only 4 bolts. Yeah, at least we get to see inside the cylinder. See if there's any problems. Okay. I'm gonna use the old orange high temp, huh? Alright. That should beat everything right there. Should pop right off, just like that. Alright. Okay. Very interesting. It's a little scored, not too bad. It's pretty good. All right. Next. Okay. So we got a piece of old tube here, and we're going to clean it up into a bushing. It is 1.65 in outside diameter. So first we want to clean this stuff up here. We got stuff on it. So let's put it in there and just clean it up a little bit first. Still feel something there. Something right there. Yeah, it's got some stuff on it right there. Let's just take that off right here. Like this. It's got some silicone on it. There we go. There we go. All right. Alright, that should be pretty good. That should be pretty good. Alright. Alright. Now, like this. Now, that's the farthest it'll go in. We'll work with it about right there. That should be fine. Alright. Now. Yeah, it's not too bad. We can work with it. Let's do a skim over it. Okay. Glasses on. Alright. That's 0. Alright, let's see what we got for diameter there, huh? 1.638, so we're good. All right. So let's take a little bit more off, not very much. We don't need very much material. We just need to make a little bit of a ring. That's probably enough material to work with right there. Alright, yeah, that looks pretty good. So, I'll go what I did with my sandpaper. Now let's see what we got for measurement wise. Got my micrometers. Not sure where it is. Oh, there it is. Right where I left it. Okay. So we're going to be fairly accurate here. So look at that old guy, huh? That's what we're going to use from now on for measuring. Whoops, not good. Okay, that looks like 1.625. Oh, that's 50 right there. 1.650. $1.643. 1.643. All right. $1.643 on our calculator. All right. Minus our measurement on our side gauge here. Hopefully you can see that, sort of. This might not work. So is that gonna be too small for this piece? No? And it's gonna be pretty thin. No? I think we might be able to check it. We're gonna have to bore this thing out and clean out the bore on the inside to make sure there's gonna be enough material to work with once we turn it down. So let's do that first and clean it up. It's pretty rusty in there. nasty. Look at that. Look at that rust cut out of there. Take another 5 thou or 10 thou off. And see, and if it's too small, it's too, or I mean, if the bore is too big for any material, we'll just have to find another piece. Uh-oh. It's a Saturday. It's a busy day. We got people doing all kinds of crazy stuff. And it's Memorial Day weekend, too. There'll be some people going to the hospital and going to the jail and all kinds of stuff. But we're not. We're going to be right here doing this because this is wonderful stuff right here. Okay, so let me see. Where's my gauge? So if this thing goes in here, all right. So it looks like it'll be thin. We'll see what we get. We'll see what we get. All right, that shouldn't be too bad. Because it's got to be smooth. If it's going to stay in the engine, it has to be smooth because of the airflow. Smooth as possible, anyway. All right. Now we got to touch off, reset our final indicator. Alright, we'll call that 0. Go a little bit more. Alright, that's where we're going to start. See what we got. Oh, we didn't. We set this. We didn't do our calculator yet. All right. So we're at about 1.5. It looks like 1.6 to me. Just under 1.6. I like to lay this thing down here like this. Okay, it is 1.5, 25, 50, 75, 71 and a half. 1571 and a half. 1571 and a half. All right. Let's do this one again. Okay. That's about right. 1.6. 1.6. 1.663. Yeah, 1.663. All right, we only have to take off 091. Okay, so let's take off 10 or 20. Off 20. See what we get. It's okay for right now. Alright, let's see what we get with this right here, and then we'll fine tune it. 1.615. 1.615. And as you can tell, we're still quite a ways over it. 1615, 1.57, 45. So let's go. That's 10, another 20. That'll be the last. We'll start using smaller increments. All right. That's probably a 5. That was the pushback of the last cut. Then we'll go a tenner, which is 20 thou. Oop, take 20 thou off. What we got. Looks like one 594. One 594. All right, well, I'll have to take off 20. 24. So we're going to come over here. We're going to take off 10 and measure. So we don't want to go over because it sucks when you go over. And we got to keep it a little bit bigger because we're going to heat up the bore on the head, and then we're going to put this in, and then it's going to shrink down on it. All right. Okay, here is the bushing that's going to go in the head. It's done. This is from the back side, the part that's going to go on the inside, and you can see the front right there. And it's made out of chrome moly. I don't know if it's 4130 or like 4340 or whatever, but it's chrome moly that I had laying around. And we're going to leave it in the lathe, because if I overbore, well, actually, no, we're not going to leave it in the lathe. It doesn't matter. All right, let's compare it, see what it looks like. See, it'll go in the other head just like that, with this bored out. So if we compare it, top, it'll sit like that in the other head. It's kind of dark. Maybe I can get a better angle. But it looks, that's the way it's just going to go in there like that. Okay, there we go. We bored our hole out, and we're ready to insert the bushing. All right, there it is. Bushing's installed with a 2 thou interference fit. And it shouldn't loosen up because the bushing should expand slightly more than the cast iron. So it should always stay tight, and we shall see. You can see inside, I'm going to have to clean up just a little bit of edge on the where they come together. But it looks good. Okay, that's what it's going to look like. I still have to get the head gasket. But that is the new bushing. Alright, I think the head gasket came. Alright, they did give me two. I was thinking they only gave me one. But, got both of them. That's what I wanted, because I want to do the other one here too. I want to resurface this. And that should go on there just like that. Huh? Interesting. Yeah, that should go on there just like that. Alright, let's push this piston up so you guys can see it. That's quite the piston, huh? Alright, that should be good. In case something fell down in around the rings, then we can push it up to wipe. Yeah, cylinder ain't that bad. Looks like could be better, but it's not that bad. everything should be fairly clean and ready to go. Just like that. Yeah, just like that. Just like that. A little bit of oil on there, not too much. Supposedly, we torque these to 16 foot-pounds, put a mark on them, and then turn them another 90 degrees. That's what the factory did. I didn't know they did that back then. Maybe it's a modern way or something. I don't know. All right. And then 90 degrees. Let's see how that works. All right, 90 degrees, huh? All right, let's see what we got. That puts it right here, right in line with that. All right, and it puts it right about right here. All right. All right, that puts it right here. Yeah, that's pretty tight. All right, that puts it right there where it's lined up with the fence. All right, that's supposed to be good. We'll see what happens, won't we?
So it's at this point that I popped the other head off and then put it in the mill and cleaned up the face. Then that's what we got right here.
Okay, there it is. This one we didn't have to replace with a bushing. We just resurfaced it. And so there's the resurfaced surface right there. All right, now we can put the head back on and move on to the next steps.
Okay, so that's a pretty good long video of watching me take it apart and put back together some stuff. So then after this, we're going to sandblast the jugs and get some paint on them so they won't rust. And then we'll start cleaning up the aluminum and doing some other stuff. We got a long ways to go.